For problem number 1, a ladder 42 feet long is placed so that it will reach a window 30 feet high on one side of a street. If it is turned over, its foot being held in position, it will reach a window 25 feet high on the other side of the street. How wide is a street from building to building? To be able to solve and to know what is the distance between building and building, we must illustrate our given. So we have here 30 feet, which is the height of one building, and 25 feet, which is the height of our other building. And our ladder is 42 feet and 42 feet. So we are going to find our A, or our adjacent. Now to solve our A for the first triangle, we can use a Pythagorean theorem, which is a squared plus b squared equals c squared, and it will be a squared equals c squared minus b squared. So a squared equals our c is 42, then squared, minus 30, which is the height of our building, squared. Then we solve. So a squared equals 42 squared is 1764 minus 30 squared, which is 900. Then a squared equals 864. Then we put square root to cancel out the squared in a, or the exponent. Then we will get a is equals to 29.39 feet. After that, we solve for the other triangle. So we can use the same process. So a squared plus b squared equals c squared. So our a squared equals to c is 42 squared minus our b is 25, which is the height of our other building, squared. Then a squared equals 1764 minus the 25 squared, which is 625. So a squared equals to 1139. So let's put square root to the both sides to cancel out our exponents. So a is equals to 33.75. Then after that, to find the distance between our two buildings, we add our two adjacent. So 29.39 feet plus 33.75 feet is equals to 63.14 feet wide, or 63 feet. And for our problem number 2, we have here, from a window 30 feet above the level ground, a building 100 feet high and at a distance of 200 feet is observed. Find the angle of elevation of the top of the building and the angle of depression of its base. So to solve again, first we need to illustrate. Since the height of our building is 100 feet high, but we have a window which is 30 feet high above the ground. Observe between a distance of 200 feet. So this is our illustration. So we need to find the angle of elevation. Since we have our opposite and our adjacent, we can use this formula, which is tangent theta equals to opposite over adjacent. Our opposite is equals to 70 feet and our adjacent is equals to 200 feet. Use our calculator to solve our 70 over 200, and we will come tangent theta is equals to 0.35. So to solve, theta is equals to the inverse of our tangent. So to do this, we can do this in our calculator using shift and pressing our tangent, and we will get the inverse tangent. So theta is equals to inverse of our tangent, 0.35. So use our calculator and we will get theta is equals to 19.25 degrees, and this is our angle of elevation. So to find the angle of depression of our base, we can use our formula again, which is our tangent theta is equals to opposite over our adjacent. So our opposite will be our 200 feet and our adjacent will be our 70 feet. So let's solve, and it will going to become tangent theta is equals to 2.8571. Find our angle, it will going to become theta is equals to inverse of our tangent and 2.8571. And let's use our calculator again, and we will get theta is equals to 70.7 degrees, and this is our angle of depression of our base. So for number 3, to measure the height of a building, a surveyor sets up his transit from a distance of 112.2 feet from the building. He finds the angle of elevation of the top of the building to be 48 degrees 17 minutes. If the telescope of the transit is 5 feet above the base of the building, how high is the building? To find the height of our building, we need to illustrate first. So our unknown is the height of our building, and we have our distance from the telescope. So we have 112.2 feet, and our angle, which is 48 degrees 17 minutes. And we have 5 feet here because our telescope is 5 feet above the ground. So to solve first, we need to convert our angle, and that will be 48 plus 17 over 60. So we will get 48.28 degrees. Since we have our angle, we can now solve for the height of our building. So since we have our adjacent and our unknown is our height of the building, which is our opposite, so we can use our tangent theta is equals to opposite over adjacent. It will be tangent 48.28 degrees equals to our opposite, which is unknown, so we put x over our adjacent, which is 112.2 feet. So to solve for our x, we multiply both sides by 112.2 feet. So we will get x equals to 100.2 feet tangent 48.28 degrees. So again, we get our trusty calculator and we compute. So we will get 125.84 feet. And since our telescope is sitting 5 feet above the ground, we will add 5 and we will get x equals to 130.84 feet, which is the height of our building. So for our number 4, we have here from the top of a tower 63.2 feet high, the angles of depression of two objects situated in the same horizontal line with the base of the tower and on the same side of the tower are 31 degrees 16 minutes and 46 degrees 48 minutes respectively. So find the distance between the two objects. So to solve for the distance between our two objects, first we need to illustrate. So we have here our two angles, which is 31 degrees 16 minutes and 46 degrees 28 minutes, and our height of our tower, which is 63.2 feet. So to find the distance between our two objects, we need to compute for our adjacent. So our adjacent is unknown, and we have here our opposite, which is 63.2 feet, and we have our two angles. So first, to solve, we need to convert our angle first. So first, we convert our first angle, which is 31 degrees and 16 minutes. So it will be 31 plus 16 over 60, and we will get 31.26 degrees. So we can solve now. So our x equals to tangent 31.26 degrees equals to our opposite, which is 63.2 feet over let's shortcut over our tangent. So let's put tangent 31.26 degrees over our tangent 21.26 degrees so that we can cancel. So we will get x equals to 63.2 feet over our tangent 31.26 degrees. So our x will be 104.11 feet, and that is our first adjacent. Solve for our second adjacent, we need to convert again. So 46 plus 28 over 60. So let's compute that, and we will get 46.47 degrees. Let's use our formula again. Tangent theta equals to opposite over adjacent. So our tangent 46.47 degrees equals to our opposite, which is 63.2 feet, and our adjacent is unknown. We'll have x equals to 63.2 feet over tangent 46.47 degrees. So we can solve now. So our x equals to 60.03 feet. Since we have our two adjacent, we can now solve for the distance between our two objects. So to do that, we can subtract the both of them. So 104.11 feet minus our 60.03 feet, and we will get 44.08 feet, which is our distance between our two objects. So number 5, a river flows at the rate of 1.5 miles an hour. So A, in what direction must a man swim in order to go straight across if his rate of swimming in still water is 2.5 miles an hour? How long will it take him to cross if the river is 1.5 mile wide? So to solve this problem again, we must illustrate. So we have a river flows, which is 1.5 miles per hour, and the rate of the man, if he swims in still water, is 2.5 miles an hour. So our question is, how long will it take him to cross a 1.5 meter wide mile, and in what direction? So to solve, we must find our c, or our hypotenuse, so that we can solve for his direction. So we use the formula a squared plus b squared equals c squared. So our a is equal to 2.5 miles per hour squared, plus our b is 1.5 miles per hour squared, equals to c squared. So let's solve. 2.5 miles per hour squared is equals to 6.25 plus 1.5 miles per hour equals to 2.25 equals c squared. So it will be 8.5 equals c squared. So find the square root so that we can cancel the exponent. So now we have our c. So c is equals to 2.23 miles per hour. So to find the man's direction, since we have here our hypotenuse and our opposite, we can use the formula sine theta is equals to opposite over hypotenuse. So sine theta is equals to opposite is 1.5 miles per hour over our 2.93 miles per hour. So we will now get sine theta is equals to 0.51. Then we solve, so we need to go for the inverse of our sine. So we have now theta is equals to inverse of our sine, 0.51. Now solve and we will get our angle. So theta is equals to 30.66 against the current. So this implies that the man needs to swim 2.93 miles per hour, 30.66 degrees against the current. To calculate the time of his swimming across the river, which is 1.2 miles wide, so we use the formula t is equals to distance over speed. So our distance is 0.5 miles over his speed, which is 2.93 miles per hour. So let's solve 0.5 miles over our 2.93 miles per hour. So it will be 0.17 hours. So a man needs to swim 0.17 hours and able to cross a 1.5 mile wide river that is flowing. So for number 6 problem, a barge is being towed north at the rate of 15 miles an hour. A man walks across the deck from west to east at the rate of 6 feet per second. Find the direction and the magnitude of his actual velocity. So here in problem number 6, we have a barge being towed towards north at the rate of 15 miles an hour. Then a man on the deck moved from east to west at the rate of 6 feet per second. So now we need to find his direction, but before that, we convert our 6 feet per second into miles per hour. So we divide our 6 feet per second over 1.467, and that will become 4.09 miles per hour. So this is the solving for our direction. Since we have our opposite and our adjacent, we can use our formula tan theta is equals to opposite over adjacent. So it will become tan theta is equals to 15 miles per hour over 4.09 miles per hour. Then let's solve. So it will become theta is equals to the inverse of tangent 15 miles per hour over 4.09 miles per hour. So theta is equals to 74.75 degrees if we calculate it in our calculator. So its direction is 74.75 degrees north of east. Then to solve for the magnitude, we can use the formula a squared plus b squared equals c squared, or magnitude equals the square root of x squared plus y squared. So in this case, I'm going to use the Pythagorean theorem. So 4.09 squared is our a because it is our adjacent, plus our 15 squared, 15 because it is our opposite, equals c because we're finding for our hypotenuse. So 16.7 plus 225 equals c squared. So if we add our 16.7 plus 225, we will get 241.7 equals c squared. Then we put square root on both sides to cancel out our exponent. So now we have c is equals to 15.5 miles per hour. So now this is our magnitude. For number 7, the radius of a circle is 100 feet. Find the perimeter and the area of a regular inscribed pentagon and a regular inscribed decagon. First, we need to find the area of our inscribed pentagon. So let's imagine that this pentagon here is inside a circle, and our circle has a 100 feet radius. So to solve for our area, we can get one triangle, and since pentagon we can get 5 triangles, so we just used one. So to solve, we need to find the angle first. So a circle has a 360 degrees. So to get the angle of one triangle, we divide our 360 degrees by 5. So 360 divided by 5 is equals to 72 degrees. Then to solve our area, we need to cut our triangle into half to have a right triangle. So we need to divide our angle, which is 72 degrees, by 2. So 72 divided by 2 is equals to 36. So our right triangle has a 36 degrees, and our hypotenuse will be the 100 feet since this is the radius of our circle. So what I did here, because this is a right triangle, I solved for the opposite, which is the b. So I use the formula sin theta is equals to opposite over hypotenuse. So sine 36 degrees is equals to, because our opposite is unknown, I put x over 100 feet. Then to get our x, or our opposite, I multiply both sides by 100 feet. So now we can cancel our 100 feet, and we will get 100 feet sine 36 degrees equals to x. So let's solve that. So 100 feet sine 36 degrees in our calculator is equals to 58.78 feet. So now, since we have our opposite, or our b, we can now solve for the height of our triangle, or the adjacent. So you can use a formula a squared plus b squared equals c squared, and it will going to become a squared equals c squared minus b squared. So a squared equals, our c squared is 100 squared minus 58.78 squared, because 58.78 is our b. So to solve, 100 squared minus 58.78 squared is equals to 6,544.91. To get our a, we put square root to the both sides, and now we get a is equals to 80.90 feet. We put square root to cancel out the exponent. So to solve for the area of our pentagon, I use the formula 1/2 times base times height times 5. So first, we will identify our base. Our base is our opposite. We just need to multiply that by 2, because earlier we divide our triangle by 2 to get a right triangle. So now we will put it back together so that we can solve the area of our triangle, and so that we can solve the area of our pentagon. So our base will become 117.56 feet times our height is our adjacent, which is 80.90 feet. Then multiply it by 5 because pentagon has 5 sides. So now when we will going to calculate it, we get the area of our pentagon is equal to 23,776.5 feet squared. Now we can solve for our perimeter. So to solve, I'm going to use the formula P is equals to A times 5. A is the edge length or the base of our triangle, and multiply it by 5 because our pentagon has 5 sides. So P is equals to the base of our triangle, which is 117.56 feet times 5. So we will get P is equals to 587.8 feet, and that is our perimeter. So now I have here a decagon. So I'm gonna use the same process. So to solve for the area of our decagon, we need to get one triangle, and after that we need to find the angle. So a circle has 360 degrees, so we divide it by 10 because decagon has 10 sides, so we will get 36 degrees. Then after that we can divide our triangle into two to get a right triangle, so that it will be easy for us to solve for the area. So after that we can divide our angle by 2 and we will get 18 degrees. So now we have here right triangle. So now since we have a right triangle, we can do the same process just like what we did in our pentagon, but change it a little bit. So I'm gonna first find our opposite. So I'm gonna use again the formula sin theta is equals to opposite over hypotenuse. So sine 18 degrees is equals to x, which is our opposite because it is unknown, over 100 feet. Then let's multiply both sides by 100 feet to cancel out. So now we have here x equals to 100 feet sine 18 degrees. So our x is equals to 30.90 feet. Just calculate it in a calculator. So our opposite is equals to 30.90 feet. Then after that, we can find our adjacent or the height of our triangle. So I'm gonna use the formula a squared plus b squared equals c squared, and it will be a squared is equals to c squared minus b squared because we are finding for our adjacent. So our a squared is equals to 100 squared minus 30.90 squared, and we will get here a squared is equals to 9045.19. So we put square in both sides to cancel out the exponent. So I have now here a is equals to 95.11 feet. So our a or our adjacent is equals to 95.11 feet. So now since we have our adjacent and our opposite, or we can say the height and the base of our triangle, we can solve for the area. So first multiply our b or our opposite by 2 to get the base of our triangle. So 30.90 times 2 is equals to 61.8 feet. So let us solve for our area. I'm going to use again the formula a is equals to 1.5 times base times height times 10 because our decagon has a 10 side. Now it will become area is equals to 1/2 times 61.8 feet times 95.11 feet times 10. So our area, if we calculate this, we will get 29,388.99 feet squared. So that is the area of our decagon. Now we can solve for our perimeter. So I'm going to use the formula P is equals to A times 10. So our A is the edge length or the base of our triangle. So P is equals to our base, which is 61.8 feet times 10, and we will get P is equals to 618 feet, and that is our perimeter.